Alright, so this video we are going to discuss the May-June 2021 paper 1-1. Alright, so first question, we are having the equation of a curve is such that dy over dx. So they give us the equation for dy over dx, and it's given that the curve passes through the point half and 4. So first they want us to find the equation of the curve. Alright, so to find the equation of the curve, equation means the y. Alright, so from dy dx, when you want to get the y, you have to do the integration. So you have to go through the integration process. Alright, so to get the y, we need to do the integration for dy dx. So integration 3x power negative 4 plus 32x power 3. Okay, so when we integrate it, we add the power plus 1. So negative 3 divided by the new power, and then plus 32 power plus 1 become x power 4 divided by the new power 4, then plus 6. Okay, so if I try to simplify it, I will have y equals to negative 1 over x power 3 plus 8x power 4 plus 6. So of course, we now want to get the value for c now. So to get the value for c, we will use the point half and 4. So the half is x, 4 is the y. So at the point half and 4, okay, so we will substitute the y equals to 4 and then half into the x. Okay, so from here, if you didn't do any careless mistake, then generally your c should be equals to the 23 over 2. So maybe I rephrase it further. Yeah, so from here you get c equals to 23 over 2. Right? And of course, I rewrite the final answer again, where my equation y will be y equals to negative 1 over x power 3 plus 8x power 4 plus 23 over 2. So this is how we solve this particular question number. Okay, so let's discuss question number 2. Alright, so for question number 2, we are having the sum of the first 20 terms of arithmetic progression is this one, and also the sum of the first 40 terms is this value. They want us to find the 60th term of the progression. Okay, so from the information that we get here, okay, generally what we get is this one. Right, so we are having the sum of the first 20 term is 405. So we are having sum of first 20 terms equals to 405. And we will want to substitute the value into the equation of S20. Alright, so what's the formula for S20? It will be n divided by 2, then 2a plus n minus 1d. So 2a plus n minus 1 is 19, d I don't know, equals to 405. Okay, so from here I will get the first equation. So 2a plus 19d, it will be equals to 40.5. So this will be my first equation. And you can find another equation from another information where the sum of the first 40 term is 1410. So the sum of the first 40 term equals to 1410. And then we substitute in the formula. So n divided by 2, 2a plus n minus 1, which is 39, d equals to 1410. So if I try to simplify this equation, then I will have 2a plus 39d equals to 70.5. And this is my second equation. Alright, so from here, very easily, we can solve simultaneous equation to get the a and d. Alright, so I can take equation number 2 minus equation number 1. I will have 20d equals to value 30. Therefore, d is equals to 1.5. And from here, substitute the d back into the first equation or the second equation to get the a. So from here, A, you will get a 6. All right, so to answer the question, they want us to find the 60th term. So T60 will be equals to A plus n minus 1D, right? So what's the value that we can substitute in? A will be 6, n minus 1 will be 59, D will be 1.5. So from here, you'll get the value for T60, which is equals to 94.5. Right, so this is how we solve question number 2. All right, so now we come to question number 3. Okay, question number 3, part A, they want us to find the first 3 terms in this expansion. So first 3 terms in this expansion in ascending power of x. All right, so for the binomial expansion, right, apply the binomial expansion formula. Okay, so we will start from the first term. So first term formula will be NC0, which is 5C0, 3 power 5, and negative 2x power 0. Then followed by the next one, NC1, 3 power 4, negative 2x power 1. And the third term will be NC2, 3 power 3, negative 2x power 2. Okay, then if you try to expand all the bracket, multiply the numbers with by using the calculator, you'll get 243 as the first term, negative 810x, 810x as the second term, and also the third term will be 1080x squared. So this is the third term. All right, so we'll stop here for the first 3 terms. Okay, then now we'll continue to part number B. Okay, for part number B, they actually want us to find the coefficient of x squared in this expansion. Okay, so we have a look here. So this part is actually what we expand from part A. So you can actually substitute the answer that you get in part A in this part. And for x plus x squared, we can actually expand it ourselves. And after that, we can try to investigate further how to get the coefficient of x squared. Okay, so first I will expand 4 plus x squared first. 4 plus x squared, if I expand it, I will have 16 plus 8x plus x squared. Then for the bracket at the back, I will substitute the expansion that we get just now in part number 8, which is 243 minus 810 plus 1080x squared. Okay, so we are going to focus on the coefficient of x squared. So by looking at the first term in the first bracket, which is 16, I will need to multiply it with the term with x squared in the second bracket to have something with x squared. So we are having 16 multiplied with 1080, then I will get 1728 x squared. So that's my first x squared. Then now I focus on the second term of the first bracket, 8x. I will want to multiply it with 810x so that I will have x squared as my final result here. So when you take 8x minus 810x, then the answer that you will get will be negative 6480x squared. Alright, then now we come to the third term, x squared multiplied with the number itself, okay, in the second bracket, so that you get also a term with x squared. So from here you have 243x squared. Then by simplifying these 3 terms all together, you have 11043x squared. And usually I will write out again. So the coefficient, or maybe I can write here. Okay, so the coefficient of x squared is actually equals to 11043. Right, so this is actually what we have for our coefficient of x squared. So you can see that when I try to expand this bracket, right, I only focus on the answer that I want, which is the x squared term. Okay, so now let's have a look for question number 4. So they give us a diagram, then they show us, they tell us that the graph is actually y equals to a tangent x minus b plus c. So given that b is between 0 until pi, they want us to calculate the value for a, b, and c. All right. So we have to try to find out the value for a, b, and c here, and then the basic graph, okay, for this diagram, the basic equation for this diagram will be tangent. All right. So maybe I will need to refer to the original graph for tangent first, where it might be helpful for us to actually find out the value for a, b, and c. Okay, so the original graph for tangent will be something like this. All right, and then original graph, the asymptote will be pi over 2 and also negative pi over 2. All right, and then one of the important points that we can use it to refer to as a reference point is this one. This is 0.00. Okay, so this is the 0.00, and it actually is the center of this whole graph. You can see that or not? Okay, it is actually the center of this whole graph. And also another one important point will be this one, which is pi over 4, because when you're having tangent pi over 4, the value for the y will be equals to 1. Okay, all right, so this is what we have for the original graph of y equals to tangent x. And now after they go through with a few transformation, right, then the graph becomes something like this, and the function of the new diagram is something like this. And we are going to try to find out the value for a, b, and c. Okay, so just now I already showed you that the reference point is 0, 0, and this 0, 0 is actually the graph for this part of the graph. So now I'm going to figure out, and I will realize that this point itself is actually the center of this part of the graph. Okay, so you can see that from original graph, it is at 0, 0, and it has been moved to this point. All right, so you can see a very clear translation in the x direction for pi over 4, and then in the y direction, in x-axis for pi over 4, and also in y-axis, okay, for positive 1 unit. All right, so this actually tells us also that the b, okay, is the unit that we move the graph, okay, in horizontal direction. So the b here will be actually the pi over 4. Okay, and of course from here also you can observe that the graph is moving up 1 unit, so the c will be a positive 1. So by using the reference point 0 and 0, we try to get the value for pi over 4 for the b and also 1 for the c. Okay, because it is a translation in the x direction for pi over 4 unit, and also in y direction for 1 unit going up. Therefore, b is pi over 4, c is equals to 1. And now we would like to figure out what is the value for the a. Okay, so to figure out the value for the a, we will look at this pi over 4 and 1. Generally, you can see that from this point to this point, the distance is pi over 4 unit, right, in x-axis. So from the center, okay, for pi over 4 unit, it will be somewhere here. And then, okay, so just now our original graph is this distance is pi over 4, and this distance is 1. But now, if you try to refer to our graph, from this distance to this distance is actually pi over 4 still. Okay, but the unit here, the difference between these two, the value of y will be 2 unit. So which means that the new graph, the y value will already multiply with 2, so that the distance okay, or the value between 1 and 0 become now 2 and 3 and 1, sorry. So the unit is 2 unit here. This one is the 1 unit, right? Therefore, it tells us that we are having a stretch in y-axis with a stretch factor of 2. So the A here will be a value of 2. Alright, so for this particular question, generally I try to compare the original tangent graph with the diagram given in the question. And also the reference point that I'm using is 0, 0 and also pi over 4, 1. So I try to compare it with the new point that we are having here. And from this, all this knowledge, right, all the point here, I actually derive and try to figure out the value for B and C first and followed by the value of A. Okay, so now we come to question number 5. So for question number 5, they tell us that 5th, 6th, and 7th terms of a geometric progression equals to this value. Given that k is negative, they want us to find the sum to infinity. Okay, so a few important keywords here. You're having the geometric progression, and then k is negative, and also they want us to find the sum to infinity. Okay, so since we know that this is geometric progression, right? Therefore, what is the r? R will be negative 12 divided by 8k, or 2k divided by negative 12. So these are my r. Therefore, I can use the relationship for this r. So negative 12 equals to 8k is the ratio, equals to 2k divided by negative 12, which is also the ratio. So ratio equals to ratio. Then from this equation, right, I will want to get the value for k. So 8 times 2 is 16. So k squared, I will have a value of 9. Therefore, k is equals to plus minus 3. But of course, we only accept one value for k, which is k equals to negative 3. So why is it k equals to negative 3? Because of in this question, they already mentioned clearly that k should be a negative value. Alright, so once you get the value for k, we can now get the value for the common ratio. So for the common ratio, it will be negative 12 over 8k. So 8k is negative 3. So from here, when you try to simplify, you'll get your ratio, which is equals to 1 over 2. Okay, so this is a common ratio, r equals to 1 over 2, which is also important for our calculation later. Alright, so besides the r equals to 1 over 2, we also need to get the value for 8. So from the information given on top again, 5th term is equals to 8k. So 5th term means T5 equals to 8k. What is the formula for T5? AR power 4 equals to 8k. So now I try to substitute all the value that I have. So r is 1 over 2 power 4, 8, and then k is negative 3. Okay, so if I try to simplify all the things here, then I will get negative 384 as the 8. Again, this is not my final answer yet because my final answer is to calculate the sum to infinity. Right, so to get the sum to infinity, it will be s infinity equals to a divided by 1 minus r. By just substituting all the values that we get just now, then eventually we'll get the sum to infinity, which is negative 768. Okay, so here we discuss question number 6. All right, they give us the equation of a curve, and then k is a constant. So the line y equals to 3x minus 4 is the tangent to the curve. And they want us to find the value of k. So tangent to the curve means that the line and also the curve intersect at one point. Okay, so we try to solve simultaneous equation since it is related to intersection, right? Okay, so my first equation is y equals to the 2x minus 3x squared minus kx. minus k minus 2. So this is my curve equation. And the line is y equals to 3x minus 4. And I'm trying to solve them simultaneously because this question, when they mention tangent, it means that the line and the curve intersect at one point. So since it is related to intersection, so I will want to solve it simultaneously. I'm having 3x minus 4, 2k minus 3x squared, and so on. But if you look at this equation, right, you're having k and x, they're having two unknowns. Therefore, you should expect that you're not able to solve it properly. Okay, but no matter how, you just try to rephrase them. Okay, so I try to rephrase the negative k, 3x, when I move it over become negative 3. So negative 3x, okay, then plus negative 4, when you move it over become positive 4 lah. So positive 4 plus 2 is 6 minus k. Then you get a 0. Okay, so I get something like this, which is a quadratic equation in terms of x. Okay, and then k are all unknown. You don't know what is the value. Okay, what is the value for k, and we want to find it out. So to find the value for k, we are using this one. This information, the line is the tangent to the curve, which means that they intersect at one point. Therefore, b squared minus 4ac should be equals to 0. So what is a b squared? Minus 4ac, and it is equals to 0. All right, so you try to rephrase everything. So you expand the bracket. All right, and then you try to expand everything here. Okay, if you didn't do any careless mistake, right, you will get 9k squared minus 54k plus 81, which is equals to 0. And also you have k squared minus 6k plus 9, which is equals to 0 as well. So you try to factorize it. You'll get k minus 3, k minus 3 equals to 0. So you can see that you have only one value of k, which is actually k equals to 3. Okay, so for this question, because of the keyword tangent to the curve, so when you try to solve it, we are using this b squared minus 4ac equals to 0. Okay, so question number 7. All right, so first part, they want us to prove this identity. Okay, so you have to prove this one equals to this, or from the right hand side to the left hand side, and so on. Okay, so for me, I think it will be easier for us to start from left hand side. Okay, so this is what we have on the left, for the left hand side. Okay, so first I can simplify the 1 minus sine square become the cos square, because cos square plus sine square equals to 1, right? Therefore, cos square is equals to 1 minus sine square. So this is the first thing that I can substitute, or I can replace. Right, so I'm having cos square theta. Then from here, you can see that on my right hand side, okay, so there are two terms. One is the first term, and then tangent square is the second term. So how can I get one and also the tangent square, the two terms here? So that means for this fraction, I need to try to separate it into two different terms. So before I separate to two different terms, I maybe can try to separate the sine square theta also. Because from here, 2 sine square theta, you can separate, become negative sine square theta minus sine square theta. Then you have negative 2 lah, right? Why I need to do so? It is because of I want to change the 1 minus sine square theta again into cos. So I will have cos square theta divided by cos square theta, then minus sine square theta divided by cos square theta. So very easily, you can see that I can get the answer that they want us to show, which is 1 minus tangent square theta. All right, so for this part, you should know that sine over cos is actually equal to tangent. And then 1 minus sine square theta, like what we applied just now, it is equal to cos square theta. So this is how we prove it. All right, so after we prove, then they want us to find out the part B. Okay, part B, a moment please. Okay, so this is what you have for part B. Okay, they want us to solve this equation. All right, for theta from 0 until 180. Okay, so to start, again, you can see that this part itself is actually the expression or equation that we have on the first part. In the first part, they actually ask us to show that this expression can be written as 1 minus tangent square. So to solve the equation here, I can straight away substitute the result that I proved just now, which is 1 minus tangent square theta equals to 2 tangent power 4 theta. Okay, so when I try to rephrase my equation here, I will actually get a quadratic form equation in terms of theta. All right. Okay, so of course I can factorize it. So tangent square theta plus 1 equals to 0. So I'm having tangent square theta equals to half. Tangent square theta equals to -1. So generally we need to ignore this part because when I want to take square root, okay, here we have a square, right? And we need to take square root. So when we want to take square root -1, it will give you a math error. All right, so this part of the answer we will ignore it. We will continue from here. Okay, so we take the square root. I will have tangent theta. When we take the square root by ourselves, we have to include the plus and minus sign of square root half. From here, I try to get the basic angle from calculator first. So the basic angle gives me a value which is 35.3. And to find out the answer for theta, from 0 to 180 degrees, that means the first two quadrants. And because of we are having tangent, and you want to consider both tangent positive and negative, therefore the answer for both first and second quadrant we need to consider. So the answer for first quadrant will be equals to the basic angle, which is 35.3. The answer for the second quadrant will be 180 minus the basic angle, so which is 144.7. All right, so this is actually our answer for from the first and also the second quadrant. All right, so now let's discuss question number 8. Okay, they give us a diagram. It is a metal plate, and then the plate is made by removing two identical pieces from a circular disc with center C. So originally it is a circular disc, and the center is a C. Okay, and then they remove these two parts. Okay, this part and also this part, which are identical to each other. So the boundary of the plate consists of two arcs, PS and QR. So this is the PS, QR, all right, of the original circle, and two semicircle with PQ and RS as diameter. So this one and also this one is actually the semicircle. So the semicircle, if you want to rephrase it or draw it clearly, right? This is a horizontal line, and this is actually the semicircle, the diameter of the circle, the small one, not the big one. Okay, so this is semicircle. This is also another semicircle. All right, so maybe I put it in red color, so easier to see. Okay, and then the radius of the circle with center C is 4 cm, and PQ equals to RS equals to 4 cm also. So these are the information that they give us. Okay, so first they want us to show that angle PCS is equals to 2 pi over 3. Okay, so to show that PCS, the angle PCS is equal to 2 pi over 3, generally what we have is something like this. This is P, this is C. Okay, so it is actually a straight line. So maybe I try to draw a straight line first. Okay, so it is 4 cm. And this is S. They want us to get this angle. Okay, I try to draw a straight line. Wait. Okay, assume that this is a straight line. Okay, so this is also 4 cm. They want us to show that this is 2 pi over 3. So how can we show? All right. So generally, what we already know is we know that C is the center of the original big circle. P is the point on the circumference, and therefore R is also another point on the circumference. All right. So from here, if I draw a line that connect P, C, and also R, we know that PCR is actually the diameter. All right. So for part A, we know that PCR is diameter. Is the diameter of that particular big circle. All right. And then if you look at this triangle here, this is a triangle, right? Okay, and from the information given, we already know that this is 4 cm, this length is also 4 cm. It is actually an equilateral triangle. Therefore, the angle for SCR, this angle itself, is equals to 60 degree, which is pi over 3, because the triangle SCR is equilateral. So that's why we know that all the three angles should be the same, which is 180 divided by 3. And you'll get a 60 degree for one angle in the triangle. So if we know that the SCR is already pi over 3, therefore, to get the angle of PCS, it will be 180. That means this whole thing minus the angle SCR, so minus the pi over 3. Therefore, we will see very easily that the angle PCS is equal to 2 pi over 3. Alright, so this is how we get the answer for part 1. They want us to prove, so this is how we show it. Okay, alright, then now we continue to part number B. Okay, so for part number B, they want us to find the exact perimeter of the plate. Okay, so exact perimeter. So that means my final answer should leave it in short form or maybe in fraction. All right, so to find the perimeter, generally we can see that it is actually consists of this length, PS and also QR. All right, PS and QR should be having the same length because they are symmetry to each other, right? So I will write it out as 2 times of arc PS. Okay, then plus, what else do we have? So we also need to consider this length and also this length, right? Okay, so PQ and SR should be the same also. So I will write as 2 times of arc PR. Okay, so how to find out the PS? So the arc PS will be R theta. So you know that the R is 4 unit, the radius is 4, right? From P to C, it is 4. So to find the arc here, you need to refer to this angle. So this angle, we already showed it in the first part just now, which is 2 pi over 3. So 4 multiplied with 2 pi over 3. Then plus 2 times of the arc PR. Okay, so for the arc PR, sorry, not the arc PR. I made a mistake here. It should be the arc SR. Sorry, SR. Yeah, so to get the arc for SR, it is actually the semicircles, the circumference for a semicircle. Okay, all right. So what we can do is like half of a perimeter of a circle. So half perimeter of a circle will be 2 pi r, right? So 2 pi, and then for this whole length here is a 4, and which is a diameter. Therefore, the radius will be 2. So half 2 pi r. 2 pi r will be the perimeter of a circle. And now we're having only half of the perimeter. So half 2 by r. So the 2 by r here will be 2 by 2. Okay, so after you get this one, we try to simplify all this. So you're having 16 over 3 pi, then plus 4 pi. Okay, so if you try to simplify everything, then you have 28 over 3 pi. So we keep it in third form, in pi form. That means we don't change it, become decimal number. Alright, so this is part B, how we find out the exact parameter of the plane. Okay, then now we proceed to part number C. Okay, so for part C, maybe I will just show it here on top. Okay, so for part C, they want us to show that the area of the plate is this length. Alright, so now how can we actually find out the area of the plate? So we need to investigate a little bit before we can start. To find out the area of the plate, generally, you can use the area of this circle. Okay, so maybe you have to try to draw out the diagram clearly. So this is actually a circle. Okay, all right, so this is actually a circle, and then if I want to get the area for the plate now, you can take the circle equation, the circle value, minus the semicircle. So where is the semicircle? So actually semicircle is like this. This is the semicircle. Okay, this is another semicircle, and they are identical. So can minus this one. All right, and after that, you also need to minus the small area here, the segment area. And these two segment areas should be also identical. Okay, so generally this is the step that you should follow. All right, so we are using the formula that we are having the area of a circle minus 2 times the area of semicircle minus again 2 times of the area of segment. Okay, so area of the circle, it will be very straightforward. It will be pi r squared, which is 4 squared, minus 2 times area of a semicircle. So the area of a semicircle will be half pi r squared. So pi, the semicircle radius is 2 so pi r squared. And now we have to minus the area for segment. Okay, so how to get the area for segment? All right, so if you have a look here again, this is a segment, right? So to get a segment, generally we are using the area of sector, the area of this whole sector, okay, minus the triangle. Okay, so minus the triangle area. So sector minus the triangle area, I will get the segment area. Okay, so 2 times. Area of sector will be half r square theta. Half is half, r square is 4 square. If it belongs to the large circle, then the theta will be this angle. So what is the angle just now that we calculate? It will be pi over 3, right? Because it is an equilateral triangle. So pi over 3 minus half the area of triangle. So area of triangle, you need to consider the A side and B side. So AB, which is 4 square also, then sine pi over 3. Okay, so this is how we actually try to find out the area of the plate. Then I try to simplify everything slowly. So 4 square is a 16 pi. For this one, I will have 4 pi after I simplify it. For this term, okay, so for this term, I'm having 16 pi over 3 pi. Then the last term here, when I multiply it in, I will have positive 16 also. And then the value for sine pi over 3 will be square root 3 over 2. Okay, so if I simplify further, 16 minus 4 minus 16 over 3, I will have 20 over 3 pi, then plus 8 sub 3. Because for this one, we can simplify, right? Okay, so this is actually how we try to calculate the area of the metal shown in the question. Alright, so it is not a straightforward question that we straight away take the large circle minus the semicircle. No, okay? Because you still need to consider the area of the segment. Alright, so this is how we solve it. Alright, so question number 9. Okay, so we are having the functions f and g. For f and g, then it is defined as follows. So these are the function for f and g. And then the domain is given for each of the function. So where a is a constant, right? So for first part, they want us to state the range of f. So to state the range of f, generally, we can look at it from the completing square form equation. So for this one, we know that the minimum point, okay, for the function fx will be 2 and -4. All right, so that means the smallest value y will be -4. Therefore, for the range of f, it will be y greater equals to -4. Okay, but of course, you need to know that the function provided here is actually a quadratic function. All right, and when you sketch it, it is a U shape where the vertex, which is the minimum point, will be at this value, this point, this coordinate. All right, so we know that the smallest value for y will be -4. Therefore, the range for the function f will be more than or equals to -4. Okay, then now we proceed to part number B. So for part number B, they want us to find the f inverse. Okay, so to find the f inverse, I will let y equals to the function fx. And after that, I will want to rephrase it, become x equals to something something y. All right, so I'm having x minus 2 that equals to, when I take the square root, I will have plus minus sign, and with y plus 4 in the square root, then x will be 2 plus minus square root y plus 4. So from here, you can see that there are two functions. One function is 2 plus something, another one is 2 minus something. Okay, so which is the correct function for our inverse function here? So to choose the correct function, we should look at the domain of the original function. So the domain of the original function is x greater equals to 2. Therefore, to get x greater or equals to 2, we need to have our function where 2 plus something, then only we'll get x greater equals to 2. So by using this way, we can decide that the f inverse should be actually 2 plus square root x plus 4. Okay, so why do we need to choose the correct range based on the domain? It is because of the range of the f inverse is actually equals to the domain of the original function f. Therefore, this is the range. Right, the function here is the range for the f inverse. Therefore, we actually need to decide by looking at the domain of the function f. All right, so we are having greater equals to 2. Therefore, we have to choose a function also here where they will give you the value which is greater or equals to 2. So this is how we decide. All right. Okay, so we have done for part B. Now we continue to part C. Okay, so for part C, I will erase all the solution here. Okay, then now let us have a look for part number C. Okay, so for part C, given that a equals to -5/3 and they want us to solve the equation fx equals to gx. Okay, all right, so to solve fx equals to gx, it will be very straightforward. You just try to equate fx equals to gx, and after that, this is fx, so 2 minus x squared minus 4 equals to gx. So gx is given that a equals to -5/3, right? So I will straight away substitute -5/3 and then x plus 2. Okay, so I try to expand my quadratic equation. And then I will try to move all the expression to one side. Then I let it equals to 0. Okay, so for this part, if you continue to simplify it, right, okay, eventually you will actually get a quadratic equation, which is 3x squared minus 7x minus 6, and it is equals to 0. Okay, then of course, we are having this quadratic equation, therefore we can try to factorize it to get the value for x. So we are having 3x 2, and then x, this is 3. And therefore we are having minus and plus here. Okay, so from here you'll get x equals to negative 2 over 3, and also x equals to 3. Okay, but for these two values here that we get, we actually only accept one answer. So which is the answer that we'll accept? So we'll accept only x equals to 3, and we will ignore this one. Why do we need to ignore the value for x equals to negative 2 over 3? So it is because of when we want to decide the value, right, they are letting we are having actually fx equals to gx. Therefore, the answer that we get, we should consider both domain from both function. So the overlapping, the smaller set of the both function of the both domain will be x greater or equals to 2. Therefore, we only accept the answer which is x greater or equals to 2. So in our solution here, only x equals to 3 fulfill this domain. Okay, the range of the domain x greater or equals to 2. Okay, so we only accept this answer. All right, so you have to double check before you decide the final answer. So since x is greater or equals to 2 from the domain, so we accept x equals to 3 as the final answer. All right, so this is how we actually complete this question. Okay, then now we continue to part number D. All right, so for part number D, they give us the function here. This contributes 5 marks. Okay, so they give us a function that GGF inverse 12 equals to 62. So they want us to find the possible values of A. All right, so we will start from the information that they give us, which is actually GGF inverse 12 equals to 62. So first, substitute 12 into the function f inverse. So where's my function f inverse just now? Okay, so from part number 2, from part B, right, we get our f inverse function, which is equal to 2 plus square root x plus 4. Okay, so I need to substitute the 12 into my inverse function here. So 12 plus 4 is 16. 16 square root is a 4. 4 plus 2 is a 6. Therefore, your f inverse 12, you will get a value 6. Okay, then now you need to substitute the 6, x equals to 6 into our function gx. So if you substitute 6 into the function gx, you have 6a plus 2, which is equals to 62. Then now you let x equals to 6a plus 2, you substitute back into your gx again. So you are having a, then 6a plus 2. This is the x, then plus 2 equals to 62. Okay? All right, so if you try to expand everything and then you group everything to one side, eventually you will get a quadratic equation also in terms of a. So you're having 3a squared plus a minus 30 equals to 0. All right, so again, you will see that we're able to factorize this quadratic equation. So I will have 3a, this is the a, and then this one can be a 3, this is 10. So I'm having a plus here and minus. Therefore, my value of a will be equals to negative 10 over 3. So another value for the a will be a equals to 3. Okay, so this will be my final answer. And then if you look at the question again, you can see that you might have more than one value of A because they are saying that find the possible values of A. All right, so this is, so we have two answers here for the value of A. All right, so now we are at question number 10. Okay, so from question number 10, they give us the equation of the circle. So this is the equation of the circle. And then they want us to find the x coordinates of the point A and B where the circle intersects the x-axis. So when circle intersect the x-axis, it also tells us that you are having the value y equals to 0. Okay, so to find the x coordinates, you just let y equals to 0 for the circle equation. So you are having x squared minus 4x minus 77, and it is equals to 0. Okay, then again, to get the x coordinate, you can factorize it because we are having a quadratic equation. 4, so can be 7 and 11. So it will be minus and then plus. So from here, you're having x equals to -7 and then x equals to 11. So these are actually the x coordinate for the point A and B. All right. Okay, then now let's continue to part B. Okay, so for part B, they want us to find the point of intersection of the tangents to the circle at A and B. Okay, so just to recall back first, so maybe for point A, I refer it as -7 and 0. Then for the point B, the coordinate will be 11 and 0. So these two values, these two coordinates is the coordinates that we get it from part A. Just now we solved it just now, right? Okay, so to find the point of intersection of the tangent, so first we need to know the tangent at A and B first. After that, only we can find out the intersection between these tangents. So now we focus on the tangent first. All right, so to calculate the tangent, generally if we are having a circle, right, and let's say this is point A, so the tangent pass through point A, it will actually be actually perpendicular, okay, from the line from center to A. So I can use this information, okay, or this property to get the gradient of tangent first. All right, so the same thing happens for the B also, okay. So now to find out the gradient of tangent, I need the center for the circle. So I need to find out the center of the circle. This is the original equation for the circle, and I rephrase it become all the x together, then and also all the y together, then I move the constant to the other side. Okay, so now to get the center, I need to do the completing square for both x and also y. So this is the x, and I start doing the completing square process. I'm having plus -2 square minus -2 square. And then the same thing happens for the y. I'm having y square plus 6y, and then plus 3 square minus 3 square, and it is equals to 77. Group the first three terms into a big bracket. I'm having x minus 2 square, then minus 4, plus the same thing happen for the y. I'm having y plus 3 square minus 9 equals to 77. And again, if I try to rephrase everything in the standard format for a circle, then you will see that we have equals to 90. So from here, the center, so the center I will label it as O lah. So the center will be actually 2 and also -3. All right, so once I get the center already, then I will start to find out the gradient of tangent. So to find the gradient of tangent, I need the gradient of OA. All right, so first I try to find out the gradient of OA, where it is y minus y1 equals to x. Sorry, the y should be a 0. Okay, so again, y minus y1 divided by x minus x1. So you're having the gradient 3 over 9, or it is actually equals to 1 over 3. Therefore, the gradient of tangent, because tangent and the gradient of OA is perpendicular to each other. Therefore, the gradient of tangent multiplied with gradient of OA equals to -1. Therefore, the gradient of tangent will be equals to 3. Okay, all right, so this is at point A. So I want to form the equation of tangent at point A. So it will be y minus 0 equals to m x minus -7, so it will become plus 7. So y equals to 3x plus 21. And this is my first equation of tangent at the point A. Then we do the same thing for point B. All right. So I want to find the gradient for the gradient for OB. So again, O is -3 now. So y minus y1 divided by x minus x1. So we are having for this case -3 on top, -9 at the bottom, and we are having 1 over 3 positive. Okay, then again, the gradient of tangent will be perpendicular. The line of tangent will be perpendicular with the OB. So to find out the perpendicular gradient, we use the same concept like just now. So you're having -3 at point B. Okay, the gradient of the tangent at point B will be -3. So again, I can form the equation of tangent at point B. So what is the equation here? Y minus y1 equals to m x minus x1. So you're having y equals to -3x plus 33. And this is my second equation. So you're having the equation of tangent for both points. And now, if you go back to the question here again, you will see that they want us to find the point of intersection between the tangent. So these two are tangent actually, and they want us to find the point of intersection between these two tangents. So when we want to find the intersection point for two linear lines, you just solve simultaneous equation. So you let 1 equals to 2. Okay, so we're having 3x plus 21 equals to -3x plus 33. Okay, so you have 6x equals to 21. 6x equals to 12, and then x equals to 2. Alright, so if you have x equals to 2, then you substitute this x equals to 2 either into equation number 1 or equation number 2 to get a value for y. So after you try to solve, you'll get the y equals to 27. And therefore, this is the point of intersection that we have. So the point of intersection, the coordinate will be 2 and 27. Okay, so this is how we solve question number 10. Okay, so now question 11, the last question for this paper. Okay, so we are having the equation of the curve, and then for first part, they want us to find the equation of the normal to the curve. Equation of the normal, and then it is at point 44, giving your answer in the form of y equals to mx plus c. Okay, so again, to find the equation of the normal, we need to find out the gradient of tangent first. So to find the gradient of tangent, generally you need to differentiate the y. Okay, so we are having y, I rewrite again into the power form, the indices form. Okay, so to find out the dy dx, you copy the constant, power you put it in front, copy the bracket, power minus 1. And you differentiate the thing inside the bracket, you get a 3 here. Then differentiate -x, you get -1. So if you try to simplify this equation, then we are having 3 over square root 3x plus 4, then minus 1. Okay, and you have to substitute the x equals to 4 into this equation. Right? So you substitute x equals to 4 into the equation here, and for the dy dx you'll get a value which is which is 3 over 4 minus 1, and from here you will get negative 1 over 4. Alright, so you need to actually know that for this value itself, it is actually the gradient of tangent. Alright, so now to get the gradient of normal, again we are using the property that gradient normal multiplied with gradient of tangent equals to negative 1 because they are perpendicular to each other, right? So the normal gradient will be equals to 4. Okay, so I have the gradient for normal already, and I also have the passing point that pass through the normal line. Therefore, I can form the equation of normal here. So equation of normal, it will be y minus y1 equals to m. M is gradient, and then x minus x1. So from here, I'm having 4x minus 16 plus 4. Therefore, the equation of normal will be y equals to 4x minus 12. So they want us to keep our answer in y equals to mx plus c, right? So this is our answer, y equals to 4x minus 12. Okay, so this is what we have for our part 1, part A. Then now we continue to part number B. Okay, so for part number B, they want us to find the coordinates of the stationary point. So to find the coordinate of the stationary point, we will let our dy dx equals to 0. So this is our dy dx, and expression is this one, right? Okay, so we can let dy dx equals to 0, and it is equals to 3 over square root 3x plus 4 minus 1. So if I try to simplify this equation, I'll get 3x plus 4 equals to 3. Then I square both sides equals to 9. And eventually I'll get a value for x here, which is 5 over 3. Okay, so this is x equals to 5 over 3, where we will get the stationary point. And we, of course, we need to know the value of x, value of y. So you substitute this equation, this value, into the equation y. Alright, so if you substitute it into the equation y and you didn't do any careless mistake, then you have 13 over 3. Therefore, you can write out again the stationary point. The coordinate for the stationary point is actually 5 over 3 and also 13 over 3. Okay, alright, so this is what we have for part B. Okay, so let's continue to part C. For part C, they want us to determine the stationary point. Determine the nature of the stationary point. Alright, so to determine the nature of the stationary point, you need to find out d square y dx square. You need to have the second derivative. Alright, so again, for the first derivative, we are having dy over dx equals to 3, and then 3x plus 4 power negative half, then minus 1. So this is my dy dx. So to find the second derivative, you need to differentiate it one more time, right? So copy the constant, power we put it in front, copy the bracket, power minus 1. So become negative 3 over 2. Differentiate the thing inside the bracket, you have a 3. Then negative 1 is a constant, right? So when you differentiate the negative 1, you'll get a 0. So there's nothing at the back. Okay, so we try to simplify this whole thing here. I will have negative 9 over 2, then 3x plus 4 power 3 over 2. Okay, then of course, to get the value for the second derivative, you need to substitute the coordinate for your stationary point. So our stationary point, right, the x is 5 over 3. Okay, so when I try to sub the value here, I will have negative 1 over 6 eventually. So the value for 1 over 6 is smaller than 0 lah. So when our second derivative value have smaller than 0, it actually means what? It means that the stationary point 5 over 3 and also 13 over 3 is a maximum point. Is a maximum point. Alright, so this is actually how we find and decide, okay, the nature of the stationary point. Okay, so this is what we have for part C. Let's continue to part D. Alright, so for part number B, they want us to find the exact area. So highlight the keyword exact area. So that means your final answer should be in fraction form or surd form or pi form. Okay, of the region bounded by the curve, the x-axis and the line. X equals to 0 and x equals to 4. Okay, so to find the area, according to what they mentioned here, right? So we should differentiate it towards the x. Oh, sorry, integrate, not differentiate. To find the area, you should integrate, okay, the function y. So the value, the limit is from 0 until 4. So 0 until 4. And then the y equation will be 2, then 3x plus 4 power half. Okay, then minus 1, minus x, sorry. Okay, so this is how we actually find the area. So to find the area, generally we just need to do the integration. So for the integration part, 2 is a constant we copy. And then you copy the bracket power plus 1, which is 3 over 2. Then you divide it with the new power 3 over 2. Differentiate the thing inside the bracket, differentiate 3x plus 4, you get a 3. Okay, so minus, when I integrate x, I'm having x squared over 2. Then later I need to substitute the limit 4 and 0. Okay, so before I substitute the limit, usually I prefer to simplify my expression first. So for the first term here, I'm having 4 over 9. Then 3x plus 4, 3 over 2. Okay, you try to simplify this part. Okay, then minus x squared over 2, then 4 and 0. Yeah, so now I will substitute the value 4 into the x here. For the first term, I'm having 256 over 9. Substitute the 4 into this part, then you are having negative 8. Then minus, substitute 0 into this equation, it will not be equal to 0. So 0, substitute it into the x. So for this part, you will have a value which is 32 over 9. Substitute the 0 into the x squared minus 2, then you are having a 0. Okay, so continue from here, you will get the a fraction which is 152 over 9. And since they want us to keep our answer in the exact form, exact area, therefore you can just leave your answer like this in the fraction. Okay, so that's all for the video, okay, about this paper, May June 2021, paper 1-1. Thank you very much for